The probability that an event B will occur given that another event A has already occurred is called a conditional probability. Usually denoted as PB bar A, read as the probability of event B given event A. It can be calculated using the formula. The probability of event B given event A is equal to the probability of the intersection of events A and B divided by the probability of event A. The probability of an event can vary depending on the condition under which it occurs. For example, let's consider rolling a single die. Suppose event A is getting a factor of 6 and event B is getting an even number. When a die is rolled and an even number comes up, how do we find the probability that it is a factor of 6? Let's verify this using a Venn diagram. First, the set for event A includes 1, 2, 3, and 6. The set for event B includes 2, 4, and 6. The definition of probability is the number of favorable outcomes divided by the total number of outcomes. In this case, since the condition rolling an even number is given, event B is treated as the total event set. Moreover, the numerator represents the cases where both events A and B occur simultaneously, which can be understood as A and B. So, if we denote the number of outcomes for event A as NA, for event B as NB, and for the intersection of both events as NA and B, then the probability we're interested in can be expressed as follows: number of event A and B over number of event B. Therefore, it is 2/3. Let's convert the number of cases into probabilities. By dividing the numerator and denominator by the total number of cases, denoted as NU, and then simplifying, the conditional probability is as follows. The numerator represents the probability of being even and being a factor of 6, which is 2/5, and the denominator represents the probability of rolling an even number, which is 3/5. Therefore, it's 2/3. You can see that it's the same as the probability we calculated initially. We'll explore more through the following table. A survey was conducted on the commuting methods of 100 ninth grade students. The two-way frequency table below shows the responses of the students. 1. Find the probability of being a male student. The probability of a male student is the ratio of all male students to all students. Therefore, it's 53/100. This is for a single event of being a male student, so it cannot be considered as conditional probability. 2. Find the probability of a student riding the school bus being a male student. The part a student riding the school bus mentioned earlier is the condition. The probability is the ratio of all male students using the school bus to all students using the school bus. Therefore, it's 36/65. 3. Find the probability that a male student riding the school bus. The part a male student mentioned earlier is the condition. The probability is the ratio of all male students using the school bus to all male students. Therefore, it's 36/53. As evident from cases 2 and 3 in conditional probability, the probability of event B given event A and the probability of event A given event B typically yield different results. 4. Find the probability that a randomly selected student using the school bus is a female student. The part a student using the school bus mentioned earlier is the condition. The probability that a randomly selected student who uses the school bus is a female student is the ratio of all female students using the school bus to all students using the school bus. Therefore, it's 29/65. See you next time!